All functional groups on amino acids carry something called a pKa. If you don't understand how to calculate a pKa value, check out the video linked in the description below. For molecules that are nonpolar or unable to lose the hydrogen that's attached to their R group, there's only a pK1 and a pK2. You can calculate something called the isoelectric point, which is the pH at which all of the hydrogens from the carboxylic acid group are gone and all of the hydrogens from the amine group are still attached. That is halfway between pK1 and pK2, or the average of pK1 and pK2, pK1 plus pK2 divided by 2. When you think about the hydrogens leaving the amino acid, because the nitrogen is already positively charged, one of the oxygens on the carboxylic acid group becomes negative, while that nitrogen is still positive. Overall, that negative and that positive charge balance out to a 0, so the overall charge on the molecule is 0, but because each side still has its own individual charge, this is called something known as a zwitterion. So when amino acids are at their neutral charge or a formal charge of 0, it's not because hydrogen has lost from the nitrogen group, it's because the hydrogen is lost from the carboxylic group, and now there is a charge on both sides of the molecule that balance each other out. When you have R groups that are capable of losing their hydrogen or adding on another hydrogen, because there's multiple functional groups that have the ability to lose a hydrogen, they're called pK1, pK2, and pK3. That's going to change what the actual pi is going to be, or the point at which the molecule is a 0 charge. If the molecule has an acidic R group, that R group's also going to lose its hydrogen at a low pH. So for example, if you have an amino acid that has pK1 of 2, a pK2 of 4, and a pK3 of 10, you're going to average the pK1 and pK2, or the 2 and 4, together to get the pi. So the pi of that molecule will be at 3. You have to compare the pK of each individual molecule with the pH of the overall environment to assign individual charges to each part of the overall molecule. And then you add all of those together. That's going to let you know what the overall charge on the protein is going to be.